If the moon vanished, the first thing we would notice is the night sky becoming significantly darker, roughly 20 to 30 times deeper in its shadow. The moon's gravity accounts for 2/3 of Earth's tides. Without it, tides would collapse to just 1/3 of their current range, driven solely by the sun. The rhythm of high and low tides would lose its lunar pulse, drastically altering the coastal flushing that many ecosystems rely on. This tidal collapse would instantly devastate coastal ecosystems, as species that depend on regular intertidal flooding would struggle to survive. The moon is not merely a light in the night sky, it is a critical biological signal. Many species, including sea turtles and various insects, rely on lunar cues for migration, hunting, and mating. If the moon vanished, the sudden loss of this nocturnal navigation tool would create immediate survival challenges. The world would shift into a disorienting, total darkness. This disorientation is just the beginning. Within weeks, the breakdown of these nocturnal cycles would trigger a catastrophic collapse in food chains that have evolved under the moon's nightly rhythm. Without these essential biological anchors, nocturnal ecosystems would be unable to sustain themselves, leading to a massive loss of global biodiversity. The moon is a fundamental metronome for our planet. Its gravitational pull creates tidal bulges, exerting a drag on Earth's spin. This process, known as tidal friction, acts as a brake, gradually slowing down our rotation over geological time. Recent observations illustrate that the length of our days experiences subtle, cyclical variations. While we see short-term trends, the underlying long-term mechanism is driven by the moon's presence. If the moon vanished, this lunar brake would be removed. The long-term trend of our lengthening days would stop, locking our rotation speed and freezing the current 24-hour cycle in place. We would lose the natural rhythm that has dictated Earth's rotation for billions of years. The moon acts as a stabilizing anchor for our planet, keeping Earth's 23.5-degree axial tilt steady. This steady tilt ensures our predictable climate zones. However, without the moon, this balance is lost. Without the moon's gravitational influence, Earth's tilt would begin to drift chaotically over thousands of years. Earth's tilt could oscillate between 0 and 85 degrees. This would result in extreme, unpredictable seasons that would render our current climate zones unrecognizable. Without the moon's stabilizing influence, Earth's axial tilt would begin to oscillate chaotically. This constant shifting causes extreme, unpredictable climate variations over thousands of years. Temperatures would swing violently between intense greenhouse heat and global ice ages, creating a snowball Earth. Historical weather patterns would vanish, making stable agriculture impossible and threatening the survival of complex life and human society. The sudden loss of the moon's gravitational pull would fundamentally disrupt the Earth's crust. For billions of years, the Earth has experienced tidal deformation, a constant stretching and relaxing of its structure. When this tidal tug ceases, the crust must adjust to the new lack of stress. This transition could trigger a surge in seismic and volcanic activity as the planet's internal pressure finds a new equilibrium. Beyond the surface, the atmosphere is also affected. The moon currently drives subtle but critical atmospheric tides. Without these tidal forces, global wind patterns, including the stability of the jet stream, would face significant disruptions, leading to erratic weather circulation. The removal of the moon essentially reconfigures the mechanical and meteorological engine of our planet, leaving Earth in a state of prolonged geological and atmospheric transition. To understand a world without the moon, we look at the Bay of Fundy. It currently experiences the world's most dramatic tidal shifts, vital for ecosystem health. Without the moon, these tides would collapse. The rhythmic flushing that cleanses coastal estuaries would cease, turning productive bays into stagnant, lifeless basins. These stagnant zones become tidal deserts. Here, oxygen is depleted, and the landscape transforms into cracked, mineral-rich flats as biological matter dies off. As this massive amount of biological matter decays in the absence of oxygen, it releases vast quantities of methane. This gas worsens local air quality and traps heat, creating a feedback loop of climate volatility. The moon has served as our planet's metronome for billions of years, regulating our climate and rotation. Without it, Earth would transition from a stable harbor to a chaotic environment, increasingly resembling the desolate surface of Mars. Our delicate atmospheric balance is also linked to this stability. The loss of our regulator would initiate long-term climatic degradation. The moon is not just a companion, it is the fundamental regulator of Earth's habitability. Its presence is what allows life to flourish.